I call here Alejandro Gutierrez, I hope I pronounce it well, director at the Integrated City Planning team at Arup in London and Milan. He will talk about circular city, and especially it will explain how circular city principle can be implemented in city to help them decarbonize their energy system, transport network, and the wider built environment. Thank you again.
Thank you very much. Sorry for being late, but there was.
Oh, it's okay. It's okay. We are actually in advance based on schedule, so don't worry.
So many thanks for the invite. I think it's really in Italiano.
No, it's in English.
Anche in English. Okay. So many thanks for the invite. We are very pleased to be here, very honored, and I think what I wanted to do is to talk about the process of implementing projects and how easy, difficult, what are the, let's call it the lessons learned and the inspirations that we pick up from our own work, and also the context in which this is happening, because I think it's relevant to also outline that this is not only a nice to have thing or let's call it a moral imperative, but it's today it's becoming policy, and because it's becoming policy, it's also making its way into mainstream, and I think that's a good thing. So this is the context in which Arup operates as a company, and I think we're all in the same page on this, so I don't need to dwell on this. I think this framework is interesting to highlight where does circular economy sit within the overall process of making our planet a sustainable place to live. So can I point with this? Yes. So circular economy sits, in our opinion, or in our mindset, within this logic, which is a logic of, let's say, the whole life cycle of a project, where you have the carbon component, the circular economic principles, and then you have the planetary boundaries, where you talk about other elements like water pollution, biodiversity, and then you have resilience, social cohesion, and health and well-being on the, let's call it, to simplify things a bit, the operational or the ongoing life of a project that is completed. So this is where circular economy sits. It is an essential part of the design process. It's an essential part of the construction process, and it's an essential part afterwards of the life of a project, but that is something I will expand on during the presentation. So it is relevant to talk about materials and material flows and the impact they have in the construction industry, within which cities sit, of course, because it is on the region of 23% of the total impact of CO2 equivalent emissions. And it has grown over time, it hasn't decreased. So we have a curve to, I mean, it's not an easy task. What I would like to emphasize is that this sits within what you probably know better than me, is that we are in a finite environment. I think the 20 years ago, 30 years ago, finance, and let's call it the world of speculation, I mean, derivatives, securitization, and the world of finance was a growth element that created certain, let's say, values and also problems. And that did not take into account that we're in a material world, that there's a finite biosphere in which we operate, which has materials, chemistry, that is finite, that has links within it that are not, you can't speculate with that. You can't triplicate things out of a stock exchange market and expect that the world will keep absorbing that. So I think that logic has permeated, and I gather from the audience and from what I was briefed, that the professions of the, let's call it engineering, science, material science, architecture, all the professions that are related, chemistry, biology, that are related to the actual material world are more relevant than ever. And I think that's a very important message I want to pass to you guys, designers, the same thing. Because we need to curb this and a few other things that you will see during the presentation. This is from the UK Green Building Council. It's the path towards zero carbon globally associated with our industry, so construction in this case, and buildings and cities, I mean construction of infrastructure. I think one of the important things is that you can see there the 23, 25% that is the yellow bit, the orange yellow bit, which is the embodied impact of construction and how we need to start doing this. So I think one thing that I wanted to, sorry, I'll go to one slide, which is here. I wanted to emphasize on that it's connected to the slide that I was showing previously, is that Europe in particular, and even more so Nordic countries, but Europe in general, I would say, and Italy is not an exception to that, particularly Northern Italy, has done a really good job on moving very quickly in the last 20 years towards energy efficiency. So the demand for energy for operational uses that we have in buildings is decreasing, and that has been a success. Now, the problem is embodied, right? So the big picture is that we've done our job, I mean, give or take, so we need to keep making it more efficient, right? But we've done our job on, let's say, operational energy. We need to now move into embodied carbon and embodied impact of materials and material flows and etc. So that is, I think, one of the big other messages that I wanted to pass to you. And then, sorry, did I miss? Yeah. And then go into the trends that I think are relevant, that are happening. Market demand is growing, but I think it is mainly growing because of this self-awareness, and I would say the pressure that is coming from, let's say, public opinion and the changing, the new generations that are changing, i.e. Greta, but she's just a representation of a wide and much wider trend. I have kids of the same age and they're all pushing in that direction, and you probably are totally aware of that. But also the regulatory context, and particularly in Europe, the Green Deal, the EU taxonomy is going, I would say, in a steady manner, moving the right direction and pushing for things that now are going to become requirements. And that is good. That is only good. So we have standards that are requiring to look at life cycle assessment of buildings, EN 15978. We have standards that require to think about adaptive and flexible buildings, EN 15643. And that is now a standard. So you can off the shelf pick it up and start using it with your clients. The point is how you are starting to enforce that, and how, for example, the PNRR is going to request this in a more or less strong fashion when projects are funded, infrastructure building projects are funded through that mechanism. And we have developed tools to do so, to support our clients, to make it very quick, to make it very efficient and very transparent and auditable and accountable. And we're very happy that we've managed in the process of, let's say, doing our own research and development and looking at trends, that we've started to pick this up. And we have tools like, for example, Inspect 3D with Maggie, which is a tool that looks at a database of embodied carbon in materials and creates the most efficient possible use of materials and design of a structure that you can in a very, very short amount of time. And that helps substantially our clients and our projects, which is not a commercial point, it's just a point about other companies are doing the same with different names. And I think the point is that we are making more systematic the response to the demands from clients and the regulatory context. We have partners. We are very proud of the partners that we're working with. We are not working in isolation. That red dot is just my mistake. Sorry for that. That has made us, I would say, pick up knowledge, give knowledge back, but create a network of knowledge and impact that we think is super relevant, because alone we're not going to do anything, nor any of those are going to be doing anything by themselves. So networking on this has been essential and fundamental to influence, to create the tools that we have, and to get into a different level of implementation. As I only have 15 minutes, I understand, I'll go, I think, straight to the projects. Sorry, I wanted to discuss this as well in the issue of life cycle. So the issues that we were, or the point that I was making about the tools that you saw before were related to the design stage, planning and design stage. The tools that I'm going to show now are related to the, let's call it the approval of the planning process. So you set up guidelines that are for third-party partners, say a city development in London, in Helsinki, in Milan, where you set out a set of requirements from the horizontal developer to the vertical developer so that they can actually meet certain parameters within your project. And also a portfolio screening tool, so that if you have already 10 buildings, 5 hospitals, 25 hotels, you can start screening your portfolio and see how those buildings, in terms of the future, I mean, what they have already as a kind of buried circular economic embodied carbon impact, how you can start improving on that, and as an investor, either pulling out, retrofitting, or improving those buildings if and when needed. Examples: the People Pavilion in the Netherlands that was done by us for the I think it's a design week in the Netherlands, in Antwerp, where we actually looked at, designed and implemented a building that was demounted completely, which brings me to a point that I think is after the challenge of measuring embodied carbon, there is the challenge of decommissioning buildings, right, and materials, which is the biggest next step after the embodied carbon, let's call it measurement and designing for reduced impact. Then there is how you're gonna decommission those buildings, reuse those materials, and that's what this is trying to demonstrate and push the boundary on. This is 2017, so it's not new, but it's a building that's completely done with reused materials, no nails, no fixed, let's call it anchorage elements, so that you could unpick all the materials and reuse them in a different building or any particular infrastructure over the next stage of the life of that project. This is a project in Amsterdam, the tallest high-rise building with a very important component of CLT. This is now almost completed, but the important point is that in this particular case, the building has on the life cycle, including the materials in scope 1, 2, and 3, a 50% reduction of CO2 equivalent emissions because of the inclusion of timber in the mixed structure that we had developed for this. This is a project in Milan, and I think that what I want to put here you have the baseline of what the building would have done. It's not a building, sorry, it's a regeneration, urban regeneration project in Milan. So this is what you would have done, meeting the requirements of the Italian regulation and the Lombardia regulation. And in this case, we are reducing certain elements of it to reduce the carbon over the life cycle of the project. This is not very, I mean, it's not rocket science today, but what I want to highlight here is that the materials element, which is there, right, which is a very relevant element in the process. As you can see here, it's almost half of the impact, is the challenge, as I was saying on the slide before, that energy, operational energy, and plug loads are a component that we are more or less getting on with. The material side is the one that needs more of a, let's say, focus and attention, and it's the challenge that we are into. This is in Provincia Autonoma di Trento, in Rovereto, and it's, again, a decision by Trentino Sviluppo to develop a cluster of sustainable companies in Borgo Sacco around the old manufactura, and with Kingokuma and Arup, we developed a sustainable master plan, which is all the structure is in CLT, and that has resulted in a massive, let's call, reduction on the CO2 equivalent embodied energy on the new part of the buildings. There is a mini hydro that provides the operational energy, and that is zero emissions practically. And I think this is a very simple, straightforward example of a client making a decision, in this case, Trentino Sviluppo, of taking let's call it a systemic approach in this particular area of circular economy and embodied impact of materials. And it's not that difficult in Italy today to achieve that. This is another project which I think is very relevant, and it's a very, I would say, how much time do I have left?
I think still 5 minutes.
Okay, good. So, because this is a interesting, tricky, and lessons learned case for us. We won a competition in Helsinki for the new district in Jätkäsaari, which is the old port of Helsinki, in 2007 or 8. Now this is all built, and we're very proud that it's built. But the client, which was the Citra, the Finnish Innovation Agency, plus a large developer, and the biggest, I mean, national actually, national level housing association, requested a project that would transition from high to low carbon impact. They didn't want a full display day one of what can be done, and they requested a life cycle analysis over 50 years for this district. And the main finding here is, in this particular case, is that the building and its operation is 10% of the problem. That the other 40 is transport, mobility, how you get in and out of the building, or the district in this case, and how the other 50% is consumption, what we consume within the buildings, the districts that we use. So if I bring water from Australia, I'm making a very extreme example, right? Whereas if I open the tap water in Helsinki, it makes a big difference. And if you take that for all the food, all the paper, for certified paper, not where is it coming from, etc., that accounts for 50% of the problem. So why am I saying this? Because behavioral change is a key element to the process of reducing the embodied carbon or the operation of anything. So the building and its bricks and its cement and its steel is an element that we're all focusing on, as we saw on the other slides, but the rest of the problem is much bigger, right? And behavioral change in a positive sense, now I'm going to explain why do I say this in a positive sense, is essential. Why? Because if you just think about the consumption side, which is 50%, right? Say the building is 10, as you can see on that green wedge there, right? If I reduce 50% of 10%, it's 5%, right? If I reduce 50% of 50%, it's 25% reduction. So if I do a behavioral change policy, which allows or requires to use more, how you call it in kilometro zero, cibo kilometro zero, no? The impact of that is much bigger than putting triple glazing, PV panels, a wind farm, everything. You can throw things at the building, right? But if you just do that behavioral change or that policy change that affects behavior in how you consume things, the effect is much bigger over the life cycle of the project. So I think that's a very important thing in terms of design. We don't need to think about design as what you actually build only. It's how you design to produce an impact. What are the outcomes of your design? And it can be behavioral change instead of only a better envelope of the building or producing energy from a different source. And I will finish with this because it's a very beautiful example from my half home country, because I'm half Italian, half Chilean. It's in Chile after the earthquake in 2010, which was 8.8 in the Richter scale. There was a tsunami, and the tsunami wiped out a very important part of the city, Constitución. And in the process of reconstruction, we were invited to help the reconstruction with a master plan. And one of the things that came out was that the cellulose producing plant here that was throwing the excess heat according to the local norms, all compliant, into the sea. And we proposed to recover the energy, the waste heat of the process of cellulose pulp making, and a social infrastructure for swimming pools was created. So a city of low to middle income in a middle income country, recovering waste heat from an industrial process, using it for piscine riscaldate, that now is a social infrastructure accessible to all the public. So this is not only about penalizing, there are many, many opportunities like this around the world, which are just win-win situations. So it's not about just policy and the stick, but it's also the carrot. And I just want to leave it there because I think it's a good example to inspire us all. I had another one, but that's, I think, a bit too late.
You can present it. Okay. Very quickly.
Last one. This is I went from a building and now I'm going to 25 million people city now in Shanghai. This is a very interesting case where we helped the municipality of Shanghai to do the urban drainage master plan. So acque piovane superficiali, la gestione del surface drainage master plan, where they have a 25 billion, well, 20 billion euro budget to build, to redo this urban drainage system for the city. You know that Shanghai is a bit like La Pianura Padana. It's very, very, very low lying, almost no gradient. And there is, in that particular case, there's more of an issue with the tide, right? So when you have rain and high tide, you can't evacuate the water. So this is a very central element over and above climate change, which is a big deal. I mean, adds only complexity to this. So one of the things that they asked us to do is to look at how we can include more blue-green infrastructure. So less, let's say, hard infrastructure works and how we can manage that. And what we did was to look at options where you could actually, by using machine learning, we looked at the quality of the soil in terms of the permeability and the actual precise datums, so that we could reduce and refine the need for civil works, i.e. Concrete channels and holding ponds and so on, and change as much as we could to green infrastructure. That allowed them to save on the region of 15 to 20% of the total budget and reduce the carbon impact, embodied carbon impact of the overall plan by 30%. Again, a saving measure, which is massive. So if you think when clients, public sector or private sector, come to you and say, well, but sustainability is really expensive. Wait, no. Sustainability is not more expensive, it's more rational, it's more efficient. And in this case, we're talking about big numbers. I mean, 10, 15% saving on 20 billion euros is what you know. I don't need to explain. Thank you.